The average length of a trout caught from a certain lake is 13.7 inches with a standard deviation of 1.6 inches. How big of a sample must be taken to ensure that the standard deviation of the sampling distribution is no more than 0.38? Alright, so the original distribution is fairly wide compared to the sampling distribution. The original has a mu of 13.7 and standard deviation 1.6. So that means, we'd have 15.3 here. And if you subtract 11.1, you'd have a mu 13.7 there. And they want the standard deviation of this new distribution to be small. They want it to be no more than 0.38. So if we did let it be 0.38 rather than 1.6, that would mean our first standard deviation above would be 14.08, and one standard deviation below would be 13.39. They want this distance to be no more than 0.38. In order to achieve that, we need the formula that relates the standard deviation of the original and the standard deviation of the new distribution. That formula is sigma x bar equals sigma over square root of n. Now we know what we want the new standard deviation to be. So if we use algebra here, the thing we don't know is going to be the n, so we'd like to solve for the n. So you get this. And then if you divide, you get that. These cancel. And you get that the square root of n is sigma over sigma x bar. We would then want to square both sides of the equation. And then we would have n alone. And we'd have this formula. Now they said the original standard deviation was 1.6. And the new one needs to be 0.38. So if you just solve that on calculator, you'll have it. $17.7. So n needs to be at least 18.